Okay, Year 10, some students have asked about some of the questions in this, and it's going to be worthwhile soon as we're in remote learning that I go over this. Gradient in linear expression is extremely important, and not only in linear expression, it comes up in advanced maths, it comes up in standard maths. It's a huge issue. It's a huge concept in mathematics because gradient means rates of change, slopes, angles, Pythagoras, right angled trig. We can use a whole lot of this. So essentially you need a definition of gradient. And gradient is just the slope, the angle. But when we talk about gradient in relation to graphs and lines, and many of you will know about gradient, like if you go up a hill that has a really steep gradient, or if you're riding a mountain bike and you go on a course that has a steep gradient, or you're riding in the Tour de France and you have a gradient of about 13%. That's quite steep. So gradient, we calculate, is the rise, how high it goes, and it can go up and go down. You can have a steep descending gradient over the run. Well, what is it again? Well, gradient is the slope, the steepness, very steep, very flat, the angle, but mathematically, to give it a number, we get the rise over the run, and we can represent that number as a fraction. We can represent that number as a percentage. We can even represent it as a decimal. Or alternatively, we can say it's an angle. And remember, from your trigonometry, you can find what that gradient is by going tan of that angle, and that will give you the gradient. So there's our definition of gradient. As you can see over here, they call it the rise over the run. It's used in everything. All right, when you're calculating what percentage of road should go up. And look, even there's a sign, steep gradient, 20%. Use, when you're going down the Moombies and trucks have to use a lower gear because the gradient going down is so steep. So all those sorts of things. The zigzag railway, the scenic railway at Katoomba, which many of you may have been on, it has a maximum gradient of 122%. That's really steep. So, don't disappear. This has been doing this to me for a while now. So linear expression, I've got to go through it all again. It's taken me back to the beginning. Okay. So just hold on there. All right. D, we're up to E. Right, there we are. So, why don't you do it again? Oh, my goodness me. Right, let's see if we can get here. Again. Right. I'm not going to increase the size this time. I'm just going to wait till I get to the spot. So there we talk about gradient, rise over run. You have a gradient going up and the gradient going down. Now, that's another important bit. So when we talk about gradient, and we talk about it in a linear form, we say y equals mx plus, now we used to say b, but now it'll say c. When you use this textbook, it's going to say b, but the new textbooks, the new syllabus guidelines, this represents a gradient. It tells you what the line is doing. So we've already done plotting lots of lines and using that formula, but we haven't actually talked about what that number does there. Now, if a line is going up, it has a positive gradient. Remember, positive and negative just tell us direction. If a gradient is going down, let's try a different color now. Come on. So if a gradient is going down, it has a negative gradient. So if I said, oh, here's this equation, and we've graphed this before, y equals 2x plus 3. Well, straight away, you know that this is going up. Left to right, when we look at it left to right, this is going to be a line going up with a gradient of 2. But if I wrote the equation y equals negative 3x plus 2, well then this gradient is negative, so this line would be going down. Okay, so here they're talking, and obviously, if it's a straight line, horizontally, it's got zero gradient. It's not going up, it's not going down. This, however, is undefined. We can't say what that gradient is. It's undefined. So, question 1, you should be able to do those. Horizontal line has a gradient of 0. Don't worry about these two. Leave them. The gradient of a vertical line, undefined. Okay. Now, all I want you to do with these is just decide whether they're positive. Well, all they ask you to do is whether they're positive or negative. And remember, we're looking at them left to right. So this one's going up, so that's positive. This one's going down, that's negative. This one's going up, that's positive. Down, negative. Down again, negative. Well, it's not going up by much, it's still a positive gradient. This one's even less, it's still a positive gradient. This one's going down, negative. This one's going down, negative. All right, and we always look at them going from left to right. So when you're looking at these, make sure you remember it is, when you look at them, from left to right, going down. From left to right, going up. Okay. Find the gradient of the following. Now remember, it's rise over run. So you just count the number of squares here. 1, 2, 3. 3 up. 1, 2, 3. 3 across. The gradient, and I'm going to use the letter M, is 3 over 3. Now you could leave it like that, but come on, we're a bit smarter than that. 3 over 3, that's a gradient of 1. And it's positive. It's going up. Let's have a look at this one. How many up does it go? 1. How many across does it go? 4. It has a gradient of 1 over 4, and it's positive. What about this one? By the way, if you can do these on your own, do them on your own. What is its gradient? Oh, the rise. Oh, but Mr. Tonkin, it's going down. 1, 2, 3. Oh, going down, negative 3. And across, 1, 2, 3, 4, 5. That's got a gradient of negative 3/5. All right. See if you can do these ones before me. The gradient of the following. Well, the gradient, and start using the letter M. It's going down negative. It's rise, 3. It's run, 8. Negative 3 on 8. This one, it's going up. It's positive. Remember, if it's positive, I don't have to put a sign. Going up, 1. Going across, 15. This one, it's going down, negative. All right, it's going down. Ooh. It's rise, 12. It's run, 4. Now, if you left it like that, that would be right. But you can go, and if you type it into your calculator will give it to you. But we always use an improper fraction. Don't make a mixed numeral. You'll go 4 goes into 12 3 times. It's got a gradient of negative 3. Okay. So that was the first bit of work, having a look at those. The next bit is looking at it on a number plane. Now, I'm not going to do all of these. I'm just going to do 2 or 3 of them. I'll do a positive, I'll do a negative. What you need to do to find the gradient, and I'll just do it here, is get the rise over the run. So here's 5a. What's the gradient? M. So what you need is you need to draw yourself a little right angle triangle. Come on, give me red. I want red. Thank you. And there it is there. But then you've got to understand what those coordinates mean. Now, the first number tells you how many across. 3. The second number tells you how many up. And because it's from 0, this one is really easy. The gradient is 6 up, 3 across, which gives me 2. And it's positive, it's going up. Let's do 5b. Again, you've got to draw a triangle. I was hoping it would give me red, but it didn't give me red. Now it's giving me red. No, it hasn't. It's changed its mind. This number, how far across? 2. This number, how far up? 10. So the gradient for B, M, it's going up, so it's positive. It's 10 over 2, so the gradient is 5. You should be recognising that the bigger the number, the steeper the gradient. So this 5 is steeper than that 2. Righto, let's have a look at a negative one. Let's go here to D. Now, don't let the negatives or positives sway you. Just look at how far it goes up or down. So here, I'm going to draw a little triangle. This number tells me how many across, 2. This number tells me how many up or down, 4. I don't care about the negative. I will later on. But at the moment, this is D. The gradient, well, it was 4 down and 2 across. And it's going down, so it's negative. So that's negative 2. Use your calculator if you need to. Now, the other questions we needed to do. You do the other ones yourself. That was questions 1, 2, 3, 4, 5. Then I said, skip 6, let's go to 9. Now, the difference is here, our triangles won't be from 0. All right? So I'm going to do a couple here. I'm going to do A, C, and E. You see if you can do the others yourself. So you draw yourself, I wanted red, thank you. You draw yourself a triangle where you can get 2 points. Remember, this tells you 9 up from 0, so that's 9 up. And even though this is a negative number, you don't care about that, it's 3 across. So the gradient here, it's going up, Just ignore the negative numbers, 9 over 3. And 9 over 3 is 3. Here you go, here's another one. Draw your triangle. It just so happens they're all on the axis. Well, this tells you it's 10 across, and this tells you it's 5 up. So the gradient is 5 over 10. But it's going down, so put a negative in front of it. And then you can simplify that and get negative, and use your calculator, a half. Just type it into your calculator. Or you can go 5 goes into itself once, 5 goes into 10 twice. And this is why I tell you to ignore the negative numbers, because if you put both negative numbers in here, you'll get a positive answer, and you should be able to see quite clearly that this is going down. Now, I tend to use the axis to draw my triangle. You don't have to draw it there. You could draw it here if you wanted to, but it's just easier to use the axis. Well, this is 2 across and 2 down, so my gradient is 2 over 2, but it's going down, so it's negative. And 2 over 2, negative 1. Once you get used to using it, you should be right. Okay, well, if this goes back to the beginning, I'm going to kill it every time I resize. There we go. Let's see if I can find it again. Now, when we use mathematics, don't you go back to the beginning. You're killing me. We can use, right, I'm just going to let it refresh a bit. I'm not going to get it too big. I don't want it to resize. We can use a formula. And I'll show you why the formula works, and then you can use it yourself. If it goes back to the beginning again, I'm going to just do it from here. So the formula, I'm going to show you where it comes from. And the formula works from using any 2 points. Now, if you're really good and you're good with formulas, I'd suggest very strongly using this. If, however, you're not and you just want to keep using the triangles, go for that. So let's imagine I've got, come on. Why are you going so slow today? Come on. All right, let's get rid of that. See if you work now. Let's go there. Go to shape. Give me the shape that I want. Go. Let's get rid of that. Go to the shape I want. Oh, come on. Right. Well, let's move this one over there. We've got 3 now. Okay. That'll be good because I can set that up. So, imagine I've got 2 points. So I'm just going to set this up. So, I've got a point here. Let's just say it's 1, 1. 1 across, 1 up. And then I go another point over here. By the way, I'll call that point A. And then I go, well, I shouldn't have put the A there because I'm going to be drawing a triangle. I'll put the A above it. 1, 1. And let's go another point, and we'll call it point B. And let's say it's 4 and 5. which means it's 4 across and 5 up. If I need to find the gradient of this line, I need to be able to draw a triangle. So let's draw a triangle in here. Now, remember, let's just deal with the going up bit. Remember these numbers, the y numbers, they tell us how far up or down it goes. So this has started at 1 and it's gone all the way up to 5. Oh, 2, 3, 4, 5. It's 4 up. An easier way to do it is just to go, 5 minus y will give me 4. What about going across? Well, these numbers tell me about going across. And again, this one started at 1 and it goes all the way across to 4. So 1 to 2, 3, 4. So it's 3. But an easier way would have been able to go 4 minus 1 is 3. Now, that is your rise, and that is your run. So if you just put a fraction there, you get the gradient. And the gradient is 4/3. Now I know that's 1 1/3, but I prefer to use it as 4/3. Now, this is where the formula comes from. I want to make that black. So if I can just click on it, let me have my, this is what I want. This thing. Let me click on this. Yes. And let's make it black. Righto. So let's now change this up. Let's say our points. Let's say our points were come on, let me draw. Let me draw. Right. Let's say my points were not any numbers, but x1 and y1. And up here, they were x2 and y2. And we'll call this point A, we'll call this point B, and we're trying to find the gradient. Well, what did we do last time? Well, to get the rise over the run, we subtracted how far up? Okay, so the gradient, we subtracted the y's, y2 minus y1, and we subtracted, to get the run, we subtracted the x values. So it was x2 minus x1. And that is the formula for gradient. Now, if you can use this, you don't even have to worry about positive, negative, or any triangles. So I'm just going to do 2 from here, and I'll show you how it works. So if we were doing 9b, and we were just using the triangles, we go, up to there, up to there. How far is it? How far is it? Remember the y values are here. How far is it from 2 to 4? It's 2. How far is it between the y values? How far is it from 1 to 5? That's 3. So the gradient positive, and it's 2 over 3. But this is what I want you to be able to do. If you're going to use the formula, write the 2 points above each other. 5, 4, and 1 and 2. And then the formula is you subtract the y values. 4 minus 2. And then you subtract the x values. 5 minus 1. 4 minus 2. Oh, I'm an idiot. Look what I did over here. I made a mistake. Lucky I did the formula. Just give it to me. I said it was 3 across. It's not, from it's 1 to 5, it's 4 across. So this is 2 over 4. Because when I do this over here, 4 minus 2, 2. 5 minus 1, 4. Let's have a look at this one. There's your triangle, although that goes over the 7, so I'm not going to have it that way. I'll try and do it really lightly. Okay, have a look at the y values. How high does it go? 7 to 1, oh, that's 6. Again, here, how does it go along the x? 7 to 1, that's 6. This is going to have a gradient of 6 over 6, which is 1. But if I use the formula, and watch again, write the points above each other, 1, 7, and 7 and 1. The gradient equals, oh, by the way, that gradient's going down, so it has to be -1. If I go, look at the top, 7 minus 1, subtract the y values. And on the bottom, subtract the x values, but you've got to do it in the same order. 1 minus 7. 7 minus 1 is 6. 1 minus 7 is -6. And when you get a negative in a fraction, you can put it in the bottom, you can put it in the top, but general practice is to put it out the front. So -6 on 6, and 6 on 6 is just 1. If you can get the 2 points, you're away. You have a go at some of those. I'm going to do E. Again, if you can write the 2 coordinates, so 2, 3, -3, -2. The gradient, subtract, I'm going to write the formula, y2 minus y1, subtract the y values, x2 minus x1, subtract the x values. Okay, and you do this on your calculator, 3 minus -2, they're the y values, over 2 minus -3. Please use your calculator. 3 minus -2, 5. 2 minus -3, 5. 5 over 5, gradient 1. Look back at the diagram. Well, that makes sense. It's going up. It has a positive gradient. And I didn't even have to worry about that. If you are brave enough, have a go at question 10. Again, just use the formula. I'm trying to shrink this without going back to the beginning. So here is 10A. I've got 1, 3, and 5, 7. I'm going to write the 5, 7 above. It doesn't matter which order you do it, it will pop out the same. The gradient, subtract the y values, 7 minus 3. Subtract the x values, 5 minus 1. 7 minus 3 is 4, 5 minus 1 is 4. That has a gradient of 1. I don't need to plot the points, I don't need to draw a triangle, I just need to write the points and use a formula. Let's take another one. Let's take E, 1, -4, 2 and 7. E. And just to show you, I'm going to write them in a difficult way. 1, -4, 2 and 7. From doing lots of these, I would have written them the other way. But it doesn't matter. Subtract the y values. -4 minus 7. They're the y values. Subtract the x values. 1 minus 2. Please use your calculator. Please use your calculator. -4 minus 7 is a -11. And you can type all this on your calculator in one go and it'll do it. 1 minus 2, -1. -11 over -1 is 11. I'll do one more. So this time I'll do F. It's got negatives all over the place. -4, -2, -1, -1. -4, -2, -1, -1. The gradient. Subtract the y values. That's these two. -2 minus -1 over. Subtract the x values. Keep the same order. -4 minus -1. Please use your calculator. And when I say use your calculator, this is what you type in. You get a fraction and you go -2 minus -1. I didn't use the negative button. I'll just go back. So where's my negative sign? Negative sign slightly higher. 1 over -4 minus -1. Please use your calculator. You get a third. Wow, how easy. If I was doing it in my head, I would have got -2 minus, that's plus, so it's going to be -1. 4 over, and I'm going to get -3, and the negatives will cancel, which gives me 1 over 3. But please, 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 just use your calculator. All right, that's gradient. If you are able to use the formula and you understand even better where it comes from, you're good. It's just the rise over the run. Subtract the y values, subtract the x values. And if you have an understanding about what gradient is and you can use a triangle, that's brilliant. Good luck.